Let us imagine that we need to retrieve some information from an ERP system running on IBM. We would like to do this instantly, so it would be great if we could simply ask a chat agent, acting as an expert, who knows how to get this information for us. OpenLegacy and watsonx can work together to seamlessly make this happen by enabling easy, non-invasive access to the data and business logic needed in order to provide the appropriate answers. First, we use OpenLegacy to generate AI-friendly API based on IBM I metadata. The generated API is made to be easily and efficiently consumed by AI engines and can be deployed in the cloud or on-premise. watsonx can easily consume the OpenLegacy APIs, creating the perfect combination of a friendly chat agent and a robust way to get IBM I data. The flow begins with the user asking a question. The AI conversational agent passes the user's question to the watsonx LLM, together with the function definitions mapped to the OpenLegacy API. Then, the LLM decides which functions to call and passes the information to the agent. The agent uses the returned functions to call the AI-friendly API generated by OpenLegacy. OpenLegacy fetches the data from the IBM I transactions and returns them to the agent. The agent calls up the LLM, passing on the user request and the results of the API calls. The LLM processes the information and returns a response to the agent. As a final step, the agent returns a natural language response to the user. From the user's point of view, the whole flow simply consists of a question followed by an answer. This is the OpenLegacy SaaS Hub, and this is the dashboard, which shows the different projects, modules, and assets. We start with the creation of the IBM I module. We select the AS400 PCML option from the different available connectors. We enter the module name and the connection details. Then we proceed with the asset generation, and we select the option to generate the asset from a PCML source file. We just drag and drop the project PCML file and click on the Add Asset button. The PCML metadata is parsed, and the input and output structures are generated. Along with that, we have a generated unit test that we can run to verify that the module is working properly. We proceed further with the creation of the project, where we enter the project name and select the REST API option. We generate the API contract by selecting the auto-generated approach with AI suggestions and the fully enriched contract option. We enter the flow editor by clicking on the generated method. Here we are validating the OpenAPI configuration and the generated input and output structures with their descriptions and mappings. To deploy the generated service, we first publish the method and click on the Deploy button. We authenticate to the service and run a test to retrieve the product details. We check the HTTP success response and the product data. Let's see how it all works together. We start the conversation by asking the status of our orders. The agent calls the watsonx LLM with the user request and the definitions of the functions that the LLM can call. The LLM decides whether to respond to the user or to call one or more functions. The LLM decided that the list orders function should be called to answer the question. The agent executes the function by calling the OpenLegacy API method. The OpenLegacy API responds with details of the orders. Then, the agent calls the LLM, providing the user request and the function call results. Finally, the LLM answers the user using natural language. Let's ask something more specific. Do we have enough stock to fulfill the open orders? The LLM realizes that data from two different functions are needed to answer the question. It also decided to use a Python interpreter to evaluate the calculations. The response clearly highlights orders that cannot be fulfilled due to stock shortages. Furthermore, the agent informs us that one of the products ordered is discontinued. The agent's thought chain is displayed after the results. We now challenge the agent with a trick question. There is no fuel pump product. The question cannot be answered. It is in fact a test to evaluate the agent's reaction to unexpected situations. The agent's behavior is correct. It tries to find the answer by calling the correct function and immediately realizes that the product fuel pump is not in the catalog.